In Chapter 9, we're going to learn about electromagnetic radiation as well as electron configurations of different atoms. So we experience different type of radiation every day, and light is a form of electromagnetic radiation. Um, Earlier in the semester, we've learned about the definition of matter. Matter is anything that occupies a space and has a mass. So now light is not a matter since it does not have a mass. And light is a form electromagnetic radiation. So it's a type of energy can travel through space at a constant speed of 3.00 times 10 to the power of 8 meter per second. And any type of radiation travel at this speed at vacuum. So light, we consider they have property of wavelengths and particles. Those particles known as photons. So light is a type of electromagnetic radiation. And electromagnetic radiation, they are waves composed of both electric and magnetic fields. And there are different type of electromagnetic radiation, including, infrared, UV, visible light, microwave, and gamma rays. So we'll talk about different type of electromagnetic radiation in a little bit. So the radiation can be visible or invisible. For example, you can see the visible light, but we cannot see the UV radiation. So this depends on the wavelengths. And wavelengths is the distance traveled between successive peaks. So they're usually expressed using Greek letter lambda, and the unit is in nanometer or meters. So if you imagine that radiation travel like a wave, just like the wave you see on the beach, and you will see the radiation travel like this. So the distance between the two peaks is what we call wavelengths. Okay. Now, frequency is the number of waves passing a fixed point in 1 second. All right. So, for example, if at this point there are 5 waves passing through this point in 1 second, we say that the frequency is 1 per second. So, obviously, if the wave moves faster, then the frequency is going to be higher and it has higher energy, and the wavelengths would be lower. So the frequency is represented with the letter nu, and the unit is 1/second or per second or hertz. And hertz and per second, they are equivalent. So wavelengths and frequency, they are inversely proportional. So if you imagine a wave come towards you, and if longer the wavelength, that means the wave goes slower, it has lower frequency, and the wave has less energy. If the wavelength has shorter wavelengths, and it has higher frequency, and then the energy associated with the wave is much higher. So dependent on the wavelengths, we can categorize electromagnetic radiation into different categories. So visible light, that's what we can visually see. It has a wavelength between 400 nanometer to 750 nanometer. So that's when we see the color. If a type of electromagnetic radiation has a wavelength within this range, then we can visually observe. So human eyes, they are adapted to see the most intense radiation from the sun. So visible light, including red, orange, yellow, green, blue, indigo, and violet. While red light has the highest wavelength within the visible light, it has a wavelength of 750 nanometer. It's right next to the infrared. So it has the longest wavelength of the visible light. That means lowest frequency in visible light and lowest energy. And violet light has a wavelength of 400 nanometer, has the shortest wavelength of visible light. That means it has the highest frequency and highest energy. So violet light is right next to the ultraviolet radiation. Now, if you have a white light source and through the prism, we can separate this different visible light based on their frequency. That's when you see different colors. Now, between 400 nanometer and 750 nanometer, which wavelengths have light has a higher frequency? So keep in mind that longer frequency, longer wavelengths, lower frequency, shorter wavelengths, higher frequency. So 400 nanometer, this will have the higher frequency. So if we put all the range of different type of electromagnetic radiation together, it gives us the electromagnetic spectrum. Electromagnetic spectrum arrange the different electromagnetic radiation by wavelengths. So from the left side, it has basically the highest wavelengths. And on the right side, it has the lowest wavelengths. So going left to right, the wavelength decreases while the frequency increases. You can see here. So the distance between the two peaks getting shorter and shorter. That means lower frequency, a lower wavelength, and the frequency gets higher and higher. So short range radiation include ultraviolet radiation, X-rays, gamma rays. So those short range radiations, they have shorter wavelengths, higher frequency. It has high energy. Okay, so now they have enough energy to potentially damage biological molecules, and gamma rays usually accompany in the nuclear radiation, and then we know that X-rays are usually used in medical diagnosis. So because of their high energy, that's one of the reason why, pregnant women or kids, they don't usually perform X-rays because of the high energy. Now, right next to the ultraviolet UV radiation is the visible light, which is the colors we see. And then those visible light have enough energy to basically cause the molecules in our eyes to rearrange. And that's why human eyes are adapted and evolved to see the most intense radiation on Earth. So this sends a signal to our brain, which results in colors we see, which is a vision. And then right next to the red light is the infrared radiation. So they are longest of the visible spectrum. They can cause molecules to bend and stretch. So this usually, if you have a heating lamp, they are infrared heating lamp. Infrared radiation is the reason that the average temperature of the Earth is around 65 Fahrenheit. And this is how greenhouse gases work. They have ability to emit infrared radiation to heat up the Earth's surface. And microwave have longer wavelengths than infrared radiation. They have enough energy to cause molecule to rotate. This is how microwave warm up food. The way it has enough energy to cause water molecule to rotate, and a lot of water molecule rotate and start to rub against each other, which produce a friction and heat. And that's why microwave can be used to heat up food. And radio waves is the longest range of wavelengths. It's used to transmit cell phone signals.